Okay, this is going to be the whole review worked out. This is going to be a very long video, but you can just fast forward to the parts that you need help on. For number 1, it tells us to differentiate the function. Well, since this one is two functions multiplied, we're going to be using the product rule. So here's f, here's g, and remember product rule, it's going to be f prime g plus f g prime. Then I labeled my two functions. If you write this in the opposite order, it's still going to give you the same answer. So I have f prime g equals, so it's going to be the derivative of the first one. So the derivative of x squared minus 2x is 2x minus 2. Then we leave g as x cubed plus 1. Plus, the first is x squared minus 2x times derivative of the second. So this one is, we're going to take the derivative of x cubed plus 1, which is 3x squared. Then we just need to simplify this, so we're going to multiply our parentheses. 2x times x cubed, not 3, is 2x to the 4th. 2x times 1 is 2x. Negative 2 times x cubed is negative 2x cubed. Negative 2 times 1 is negative 2. X squared times 3x squared is 3x to the 4th. Negative 2x times 3x squared is negative 6x cubed. Then we just need to combine our like terms. So 2x to the 4th and 3x to the 4th equal 5x to the 4th. Negative 2x cubed and negative 6x cubed is negative 8x cubed plus 2x minus 2. And that's going to be our final answer here because this can't be simplified any further. Okay, number 2. This one is another product rule, but we need, it's going to be a trig derivative here. So still our first function f is x squared. The second one, g, is tangent. So we're going to take the derivative of the first one, and we get 2x. Then we leave g of x the same, so times tangent of x, plus f, which is x squared, times the derivative of tangent, which is secant squared x. So then our final answer here is just 2x tangent of x plus x squared secant squared x. So there's really no simplifying that we're going to do here. Okay, the third one, this is going to be quotient rule. And we have f on top, g on the bottom. Remember, quotient rule is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So if we just use f and g, it'll be the bottom. So x squared minus 4 times the derivative of the top, and the derivative of cosine is negative sine, minus the top, which is cosine x, times the derivative of the bottom, which is 2x, all over the bottom squared. So x squared minus 4 squared. So now I'm just going to simplify this by distributing this negative sign. So it's going to be negative x squared sine x And then negative 4 times negative sine is positive 4 sine x. Then minus 2x cosine x. Then we're not going to multiply out this bottom. We're just going to leave it as x squared minus 4 squared. And that would be our final answer. Okay, number 4. This time we're going to write the equation of a tangent line at the x value. So these are multiplied, meaning we're going to use product rule. So f and g. First step, let's find the derivative to get our slope. So it's going to be the derivative of the first. Derivative of x squared minus 3 is 2x. Then times g plus the first times the derivative of the second is just 1. Now there's no need to simplify this because we're going to be plugging in this x equals 1 to find the slope. So let's just plug in the 1. So it's going to be 2 times 1 times 1 plus 4 plus 1 squared minus 3 times 1. So then this would be 2 times 5 is 10. 1 minus 3 is negative 2. So then our slope here is going to be 8. We almost have enough to write the equation of the tangent line now, except we don't have our y value. So to find the y value, I'm just going to take the original, not the derivative, and we're going to plug in 1. So it'll be 1 squared minus 3 times 1 plus 4, which means our y value is going to be negative 2 times 5 would be negative 10. So our point here is going to be 1, negative 10 with the slope of 8, which means our equation is y plus 10 equals 8 times x minus 1. And that would be our answer. Okay, number 5 is going to be the same thing, except instead of product rule, we're going to be using quotient rule. First up, we find the derivative. And the top is f, the bottom is g. Remember, our quotient rule is bottom times derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. So it'll be x plus 2 times the derivative of the top is just 1 minus x minus 3 times the derivative of the bottom is 1 as well, all over x plus 2 squared. Now again, there's no real reason to simplify this because we're just plugging in our x value to find the slope. So f prime of 0, that's going to be 0 plus 2 is 2 minus 0 minus 3. So that's going to be negative 3 all over 0 plus 2 squared is 4. Negative 2 minus negative 3, that's 2 plus 3. So 5/4 is going to be the slope. Now we need to figure out what our y value is. So I'll take my original equation and I'll substitute in a 0. So 0 minus 3 over 0 plus 2, which means my y value is negative 3/2. So my point that we'll be using is 0, negative 3/2. So the equation would be y plus 3/2 equals 5/4 x minus 0. And that's our final answer. Okay, on to the back. So this time it tells us what f prime of 2 is, or we're finding f prime of 2, and it gives us g, g prime, h, and h prime. So we're just going to have to use our rules here, but arbitrarily. So f prime of x equals, it'll be 2, and then times derivative of g plus the derivative of h. So these are just like the ones that we would add. We just take each derivative separately. So f prime of 2 would be 2, and then g prime of 2 is negative 2, plus h prime of 2 is 4. So negative 4 plus 4 would equal 0. So f prime of 2 equals 0. On number 7, we're going to be using the quotient rule. So we have, this is our f, this is g, and it's going to be bottom times derivative of top minus top times derivative of bottom all over the bottom squared. So if we write it in terms of g and h, it's going to be the bottom, so h, times derivative of top, g prime of x, minus the top, so g of x, times the derivative of the bottom, so h prime of x, all over h of x squared. So now we just have to plug in the values that they give us. So h of 2 is going to be negative 1. G prime of 2 is going to be negative 2. Minus g of 2 is 3. H prime of 2 is 4. And then h of 2 again is negative 1. So we simplify this, we get 2 minus 12, so that's going to be negative 10. Negative 1 squared is just 1. So our answer for f prime of 2 is negative 10. Okay, g, this time it's going to be the same thing except for using product rule. So here's f, here's g. So it'll be a derivative of the first, so that's g prime of x, times the second, plus the first, times derivative of second. So now we want f prime of 2. G prime of 2 is negative 2. H of 2 is negative 1. Plus g of 2 is 3. H prime of 2 is 4. So we get 2 plus 12 equals 14. So f prime of 2 is 14. Number 9 wants us to figure out what the second derivative is. So we'll start by taking the first derivative. So 3 times 1/3 is just 1. X squared Derivative of 4x is just going to be 4. And that's going to be the first derivative because the derivative of negative 7 is just 0. Now for the second derivative, I just do the same thing again. Derivative of x squared is just 2x. Derivative of 4 is 0. So our second derivative is just 2x. Okay, the second one, we have product rule because there's an x and a cosine x. So we'll split it. We have f and g. Our first derivative is going to be the derivative of the first, which is 1, times the second is cosine, plus the first, so x, times derivative of second is negative sine. So this right here would be our first derivative, but we need the second derivative. 1 times cosine is just going to be cosine, and the derivative of cosine is negative sine. Now we have x times negative sine. We're going to have to use product rule here. Derivative of the first, so the derivative of x is 1 times the second, so it would be negative sine x, plus the first, which is x, times the derivative of the second. So the derivative of negative sine is negative cosine. Now we can just simplify this. So we have negative sine and negative sine. Those would add together to give us negative 2 sine x. Then minus x cosine x. And that's going to be our final answer for the second derivative. Number 11, we need to figure out what points this graph has a horizontal tangent. So to figure that out, we need to find the derivative and then set it equal to 0. To find the derivative, we need quotient rule. So f prime of x equals the bottom times the derivative of the top. Derivative of the top is just 1 minus the top times the derivative of the bottom, which is 2x, all over the bottom squared. Now we need to simplify the top. So it'd be x squared plus 3. Then I'll distribute the negative here. Negative x times 2x, negative 2x squared. 1 times 2x is 2x. Then I can leave the bottom as x squared plus 3 squared. Almost done. We have two like terms. So f prime of x equals negative 1x squared plus 2x plus 3. Now to find the horizontal tangent, I want to set this equal to 0. So to figure out when this equals 0, we only need to worry about the top, because if the top equals 0, then the rest of it equals 0. So I have negative 1x squared plus 2x plus 3 equals 0, which means I just need to factor this side. But to make it easier on ourselves, I'm going to factor out a negative 1. So this would become x squared minus 2x minus 3 equals 0. When we factor this, we get x minus 3, x plus 1, So we'll have a horizontal tangent when x equals positive 3 and x equals negative 1. Okay, now we're getting to the multiple choice part. So number 1, it gives us h of x equals sine x cosine x, and it wants to know what the derivative of h is when x equals 3 pi over 2. So notice here we have a chain rule, not chain rule, product rule. So here's f and here's g, which means h prime of x would equal derivative of the first, derivative of sine is cosine, times the second, so cosine, plus the first, which is sine, times the derivative of the second, derivative of cosine is negative sine. So derivative of h is going to equal cosine squared x minus sine squared x. But it wants the derivative when x equals 3 pi over 2, so I just need to substitute in 3 pi over 2 for x. So cosine squared of 3 pi over 2 minus sine squared of 3 pi over 2. Now 3 pi over 2, this is a unit circle thing. And we know cosine of 3 pi over 2 is just going to equal 0. So it'll be 0 squared minus sine at 3 pi over 2 is going to be negative 1. So our final answer here is 0 minus 1, which equals negative 1. So B would be our answer. Number 2, we don't have to use any special rules here because we are just adding. But I do want to change this 1 over x squared to be x to the power of negative 2. So now I need to take the derivative. So f prime of x equals the derivative of negative x to the 5th is going to be negative 5 x to the 4th. Derivative of x is just 1. And the derivative of x to the negative 2 is negative 2x to the negative 3. Which would equal negative 5x to the 4th plus 1 minus 2 over x cubed. But that's not what this question's asking for. It wants the derivative when x equals negative 1. So I'll replace the x with the negative 1, and I get negative 5 times negative 1 to the 4th plus 1 minus 2 over negative 1 to the 3rd. Negative 5 times negative 1 to the 4th. Negative 1 to the 4th is just 1, so negative 5 plus 1. Negative 2 divided by negative 1 to the 3rd would be negative 1. Negative 2 divided by negative 1 is positive 2. So negative 5 plus 1 is negative 4 plus 2 is negative 2. So f prime of negative 1 equals negative 2, or B. Number 3 may look like it's going to be a quotient rule, but notice there's no variables on top. So this is actually going to be a chain rule, because we can rewrite this bottom as a negative exponent. So y would really equal 3 times 4 plus x squared to the power of negative 1. Now we do chain rule, so y prime equals, the outside is the 3 and the exponent to the -1. So we're going to leave this 4 plus x squared. That's going to be the inside. So if we take the derivative of this, we multiply by -1, so it's -3. Leave the inside as 4 plus x squared. And then I take the power down 1, so -2. But because it's chain rule, I need to multiply by the derivative of the inside. The derivative of 4 plus x squared is going to be times 2x. So when I simplify this, we get -3 times 2x is -6x all over 4 plus x squared squared. So I brought that negative exponent to the bottom. And if we look here, it matches A, so A would be our answer. Okay, number 4. This one's going to be another chain rule because it looks like cosine x, except the inside is not x. It's x cubed instead. So our outside here is going to be cosine. On the inside, we have x cubed. So our derivative, we first take the derivative of cosine, and we get negative sine. And remember, we leave the inside the same, so it's going to stay x cubed. But since x cubed was my inside, I need to multiply by the derivative of that, which is 3x squared. So my derivative equals -3x squared sine of x cubed, which matches B. Okay, number 5 looks like it's really hard, but it's just taking the definition of a derivative. So the limit definition of a derivative, which remember was the limit as h approaches 0 of f of x plus h minus f of x all over h. So you see how these are very similar. From this, we can figure out what f of x equals. So f of x is just going to equal sine of pi over 6. So basically all they're asking in this problem is they want the derivative. So if f of x equals sine of x, all they want is the derivative at pi over 6. And we know the derivative of sine is going to be cosine, and we replace that x with pi over 6. So f prime of x is just going to equal cosine. And then it told us what x equals. It was pi over 6. That's what we plugged in, pi over 6. And using your unit circle, sine or cosine of pi over 6 is going to equal square root of 3 over 2. And that's our answer, so D. So this looks like a limit problem, but really it's just telling you to take the derivative. You just now have to know what f of x equals. Okay, number 6, it wants the equation of the tangent line of y equals x plus 3 over x squared plus 1. So this one is obviously quotient rule because we have a function on the top and a function on the bottom. So here's our f, here's g. First step, when we're finding the equation of a tangent line, we need to find our slope, which is the derivative. So y prime is going to be the bottom, which is x squared plus 1, times the derivative of the top, which is 1, minus the top, which is x plus 3, times the derivative of the bottom, just 2x, all over the bottom squared. And once again on these, there's no point in simplifying it because all we're doing is we're going to plug in this x value to figure out what our slope is. So it's going to be 1 squared plus 1 times 1 minus 1 plus 3 times 2 plus 1 all over 1 squared plus 1 squared. When we simplify that, 1 squared plus 1 is 2, minus 1 plus 3 is 4, times 2 is 8. So 2 minus 8 would be negative 6 over 1 squared plus 1 is 4. 2, just kidding. 2 squared, which is 4. So our slope here is negative 6 over 4, which is also, when you simplify it, negative 3/2. So that's our slope. Now if we look at these problems over here, the answer choices, we should be able to identify the slope as negative 3 over 2. D and E have the slope of negative 3/2. A, B, and C do not. So we've already eliminated 3 answer choices. Now all I need to do is figure out what my y value is. So I'll take y, and I'm going to substitute in a 1. So it's going to be 1 plus 3 over 1 squared plus 1, which equals 4 over 2, or 2. So my point is 1, 2. So my equation here is y minus 2 equals negative 3/2 x minus 1. Our answer choices are not in point slope form though, they are in slope intercept form. So I'm going to have to simplify this. So I get y minus 2 equals, distribute the negative 3/2. And then I add 2 to both sides. Now negative 3/2 plus 2, this is the same thing.
Can you call the right office 3800, please? Thank you.
As plus 4 over 2, which means our final answer here is negative 3/2 x plus 7/2. So D is the answer. Okay, number 7. It gives us a function and it wants to know what the derivative of f of g of x is. So all we're really doing here is chain rule. So first step with chain rule is we need to take the derivative of the outside. Derivative of the outside, that's going to be the derivative of f of x. So if we look at the derivative of f of x, it's going to be 6x. But remember with this, the x is really g of x. So it's going to be 6 of g of x, because with chain rule, you leave the inside alone. So it's not x, it's actually going to stay as g of x. But also with chain rule, you have to multiply by the derivative of the inside, which would be times g prime of x. So our answer would be D. Be careful not to pick C. Notice how it has an x here. That would be like if we changed the inside of a chain rule to just be x instead of what the actual function was. Okay, number 8. Now this one has square roots, and those are hard to deal with. So we're going to change them into fractions. So f of x is really going to be 2 times x to the power of 1/2 plus 9 times x to the power of negative 1/2. Now this is much easier to take the derivative of, and we want the derivative when x equals 9. So f prime of x is going to be 2 times 1/2 is just 1. So x to the negative 1/2 plus 9 times negative 1/2. So I guess this one changed to a minus. So it'd be minus 9/2 times x to the negative 3/2. Now I'm going to rewrite this. So f prime of x is going to be 1 over the square root of x minus 9 over 2 times the square root of x cubed. So I just kind of I put them on the bottom, and then instead of leaving it as a fraction, I changed it back to a radical. So I'm going to take this. Last step is to substitute in the 9. So f prime of 9 equals 1 over the square root of 9 minus 9 over 2 times the square root of 9 cubed. 1 over square root of 9, of course, is 1/3. Now let's deal with this here. So we can take the square root of 9 and we get 3. Then 3 cubed is going to be 27. So minus 9 over 2 times 27. I'm going to come up here to finish this. So it'd be 1/3 minus 9 over 54. Which is really 18 over 54 minus 9 over 54. So we get 9 over 54 as our answer, which simplifies to, if we divide by 9 over 9, to 1/6. So our answer is D. Okay, number 9. This one is just a normal derivative problem. We don't have to use product rule because there's this subtraction sign in between. But we do need trig derivatives here. So it's going to be y prime equals, first we need the derivative of tangent, which is secant squared. Then minus the derivative of cotangent, and the derivative of cotangent is negative cosecant squared. So minus negative cosecant squared. So now minus a negative, that'll change into a positive. So y prime is secant squared x plus cosecant squared x. So our answer would be E. Number 10, we need the equation of the line tangent to this graph. So once again, we need to find the derivative so we can get the slope. And then we have to plug in x and y to get the equation. So y prime equals, this one again, we don't need product rule or anything because there's a subtraction sign in between. So the derivative of 3x is just 3. Derivative of negative cosine, so minus derivative of cosine is negative sine x, which means our derivative is 3 plus sine x. But we want the derivative when x equals 0. So y prime equals 3 plus sine of 0. Now sine of 0 just equals 0. So our slope here is 3. And like we did on that last problem, you can go ahead and cross out examples. So A That has a slope of 2. C has a slope of 2. D has a slope of 4. So we know it's going to be B or E. Now I need to find my y value. So I'll take my original equation and replace x with 0. So y will equal 0. Cosine of 0 is going to be 1. So y would equal -1, which means our point here is 0, -1. So y plus 1 equals 3 times x minus 0, which means y plus 1 equals 3x. Then I subtract the 1, so y equals 3x minus 1, which means the answer here is B. Okay, number 11 is actually wrong on the sheet where it's all worked out because we forgot the sign there, but this one will be right. So here we have product rule. Here's our split. This is F and this is G. So f prime of x equals derivative of the first. Now we need a chain rule here because the inside is not x and we have a squared. So it's going to be 2 times, I leave the inside the same, so x minus 1. And then this power becomes a 1. But our inside was x minus 1, so I have to multiply by that derivative. However, the derivative of x minus 1 is just 1. So it's not really going to affect this one. Times, we leave the second one alone, sine x plus x minus 1 squared times the derivative of the second. Derivative of sine is cosine. Now this one looks really ugly to clean up, but don't worry because we don't have to. It just wants the derivative when f prime is, when x equals 0. So I'm just going to plug in a 0 here. F prime of 0 equals 2 times 0 minus 1 is -1 times sine of 0 is 0 plus 0 minus 1 is -1 squared would be a +1. Cosine of 0 is 1. Which means f prime of 0 equals -2 plus 1 oh wait, just kidding. I did that wrong. This is all multiplied by 0. So it's 0, not -2, sorry. -2 times 0 is just 0. 1 times 1 is 1, which means our answer is 1 or D. Okay, number 12. This time it gives us a table with all of our derivatives and values given. And we're just using f and g of x again. So h prime of x, we need to use quotient rule. So it's going to be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And it wants the derivatives when x equals 2. This table gives us everything when x equals 2. So I'm going to use these 4 values here, which means h prime of 2 equals g of 2 is -2, f prime of 2 is pi, minus f of x is 6, g prime of x of 2 is 0.5. all over g of x squared, so negative 2 squared. So we just use this table up here to fill in all of our values. When we simplify this, negative 2 times pi is negative 2 pi. Negative 6 times 0.5 is negative 3. All over negative 2 squared is 4. So it's going to be negative 2 pi minus 3 over 4, which gives us the answer of A. Okay, number 13. So it says if f of x equals x to the 3/2, it wants to find the derivative when x equals 4. So f prime of x equals, the 3/2 goes in front, x, 3/2, I subtract 1, and I get 1/2. Which is going to be the same thing as 3 square root of x over 2. And when I plug in my 4, so f prime of 4 equals 3 times square root of 4 over 2, which equals 3 times 2 over 2, which would equal 3. So C is our answer. Okay, 14. This is just a normal derivative. There's no special rules here. F prime of x equals, derivative of x is just going to be 1. Derivative of sine is just going to be cosine. And that's all there is to this one. So our answer is A. Number 15, we have a normal function and it wants the second derivative. So be careful that look what derivative it's asking for. There's 2 little 2's here. That means it's the second derivative. So it's going to be y prime. So the first derivative would be 5 over 10 x to the 4th plus 4 over 2 x to the 3rd. Derivative of negative 2/5 is just 0. And we can make this look better. 5 over 10 is just 1/2. 4 over 2 is just 2. So if you weren't careful, you could, actually the first derivative isn't even an answer. The second derivative, we need to do it again. So multiply by 4. 4 times 1/2 is 2. X to the 3rd plus 2 times 3 is 6. X squared. So our second derivative here is 2x cubed plus 6x squared, which would be E. Okay, next one. So here's another one that looks like it's going to be really hard, but all it really wants is to use the definition of a derivative. So we need to identify what f of x equals. So this right here is going to be our f of x. So f of x equals sine of x. Since this is the definition of a derivative, we need to figure out what f prime of x equals. The derivative of sine is cosine, which means our answer is A. Number 2. Yes, these are numbered really weird. So here's just a normal quotient rule problem. We have the top is f, the bottom is g. So y prime is going to equal the bottom, 3x plus 2, times the derivative of the top, which is just 2, minus the top times the derivative of the bottom, which is 3, all over the bottom squared. And I just need to simplify this top by distributing. So y prime equals 3x plus 2 times 2 would be 6x plus 4. And then 2x plus 3 times 3, that's going to be negative 6x minus 9, because you have to distribute the negative. So negative 2x times 3 is negative 6x, negative 3 times 3 is negative 9. Now I can still simplify this. 6x minus 6x, those cancel out. 4 minus 9, it's going to be negative 5 over 3x plus 2 squared. So D would be the answer. Okay, number 3. This one's gonna be product rule. If we look here, we have f and g. So y prime is going to be derivative of the first, which is 2x, times the second, which is sine of 2x, plus, we leave the first alone, times the derivative of the second. Now be careful here, sine of 2x, this is going to be a chain rule. So the outside here is sine, derivative of sine is just cosine, but we leave the inside as 2x. So here's our inside of 2x, so I also have to multiply by that derivative, which is a 2. Now I can simplify this. So y prime equals 2x sine of 2x plus 2x squared cosine of 2x. None of my answer choices look like this quite yet. So notice they factored out a 2x up here, which is probably what I need to do as well. So y prime equals, factor out a 2x to see if that helps. And I'm left with sine of 2x. 2x squared, factor out a 2x, we're left with x. And then cosine 2x. So now 2x, sine of 2x, it's not minus, it's going to be plus. That tells us the answer is going to be E. So E matches. So that was a product rule and a chain rule together. Number 4. This one is a chain rule. So y prime equals, the inside here is x cubed plus 1. The outside is just the squared, so it's going to be 2. We'll leave this inside as x cubed plus 1. Then that power becomes a 1, but we don't need to write it. The inside was x cubed plus 1, so I need to multiply by that derivative, which is 3x squared. So my final answer here, 3x squared times 2 is 6x squared times x cubed plus 1. Which means my answer is E. All right, 5. This one's going to be another chain rule, but I want to rewrite it first so I don't have a square root. So it'll be 4 sine x plus 2 all to the power of 1/2. Chain rule again, so the inside is this 4 sine x plus 2. So y prime would equal 1/2. Inside would stay the same, so 4 sine x plus 2 to the negative 1/2. But I need to multiply by the inside derivative. Derivative of 4 sine x plus 2 is just going to be 4 cosine x. Now I'm going to rewrite this to make it easier to plug in 0, but we're not going to simplify completely. So y prime is going to be 1 over 2 times the square root of 4 sine x plus 2 times 4 cosine x. Now up here, I just need to figure out what it's going to be when y prime equal, or when x equals 0. So I'll just plug in a 0. And that's going to be 1 over 2 square root of 4 times sine of 0. Sine of 0 is just 0 plus 2 times 4 cosine of 0 is 1. So I get 4 over 2 square root of 2, which equals 2 over square root of 2. Sorry, that's ugly. But we don't have an answer here because we have a radical on the bottom, which means we need to rationalize that. So 2 over square root of 2, we can multiply the top and the bottom by square root of 2. So I get 2 square root of 2. Square root of 2 times square root of 2 is just 2. These 2's cancel out, and we're just left with square root of 2 as our answer. So B. Okay, number 6. This one again looks like it's going to be quotient rule, but it's actually chain rule because there's no variable on top. So I'm going to rewrite y as 3 times 4 plus x squared to the negative 1. Then when I do chain rule, the inside is going to be the 4 plus x squared. But I always start with the outside. So y prime equals negative 3 times 4 plus x squared to the negative 2. But then since it's chain rule, I need to multiply by the derivative of the inside. Derivative of 4 plus x squared is 2x. Which means y prime equals negative 6x over 4 plus x squared squared. Which means the answer here is C. Okay, 7. They give us two functions, and we need to figure out what h prime of x is. So we need to use our rules here, but there's no actual functions. It's given in function notation. So we're going to start off h prime of x. This first part here uses quotient rule. Not quotient rule, product rule. These two are multiplied, so it'd be product rule, which means we need derivative of the first. Derivative of x squared is going to be 2x times the second, which is g of x. Plus, we leave the first as x squared times the derivative of the second, so g prime of x. Now for this part, this is chain rule, so it's going to be minus derivative of f, but I leave the inside as 3x plus 1. But since it's chain rule, I can't forget to multiply by the derivative of the inside. So the derivative of 3x plus 1 is 3. So now I just need to simplify this, which means h prime of x equals 2x g of x plus x squared g prime of x minus 3 f prime of 3x plus 1. And if we look, E isn't in the right order, but it just flipped these two, so E is our answer. Okay. 8, we're again using a table, and notice it wants g prime of 2. So we're going to be looking when x equals 2. Now, on the work through notes, we made this an f of x to the negative 1 power, but I'm going to show you using chain or quotient rule just as another way to do it. So g prime of x equals the bottom, so f of x, times the derivative of the top. Derivative of 1 is just 0, minus the top, times the derivative of the bottom, so f prime of x, all over f of x squared. But now I need my values when x equals 2. So g prime of 2 equals, well, if I look, f of 2 is going to be negative 8 times 0 minus 1 times f prime of 2 is negative 4, all over f of 2 squared, so negative 8 squared. We simplify this, negative 8 times 0 is 0, negative 1 times negative 4 is 4, negative 8 squared is 64. Divide the top and the bottom by 4, and I get 1/16. So we get D. So really here you'd either be using chain rule or quotient rule. It's really up to you, whichever one you think is easier. Okay. 9, this is another one that doesn't really use real functions. It just gives us the function notation. But it wants chain rule here, so f of g of x. That means h prime of x is going to equal f prime, but the inside stays the same, so it's still going to be g of x. But since it's chain rule, we need to take the derivative of the inside and multiply it. So times g prime of x. And it wants h prime of 1, so I'm going to replace the x's with 1s. So h prime of 1 equals f prime of g of 1 times g prime of 1. And if I look, f prime g of 1, right here it says it equals 3. So f prime of 3, g prime of 1 is negative 3. And if I look again, f prime of 3 is negative 5. So negative 5 times negative 3 is going to equal positive 15, C. So you really have to know your rules to do these problems. All right, next one. This one is chain rule. Its sign will be on the outside, 3x is on the inside. So y prime equals derivative of sine is cosine. We leave the inside the same as 3x. But since it's chain rule, I need to multiply by the derivative of 3x, which is 3. So y prime would equal 3 cosine of 3x. which means our answer is E. This one is product rule. So here's F, here's G. So y prime equals derivative of the first is 2x times the second I leave as sine x plus x squared times the derivative of the second, which is cosine. Now notice I don't have the answer in any of these, but I can factor out an x. So y prime is going to be x 2 sine x plus x cosine x. And these are in a different order, but it does match C. So the x cosine is first, then the 2 sine. So C is the answer. K12, we have cosine squared of x, and it wants the second derivative at pi. So f of x, it'll probably help to write it like this. Now we're going to need chain rule. So f prime of x equals 2, leave the inside the same, but the inside is cosine of x, so I'm going to multiply by negative sine x. So f prime of x, just to clean this up, it's going to be negative 2 cosine x sine x. Now it wants the second derivative, so I'm going to have to do this again. So f double prime of x, we're going to do product rule. So I split it in half. Here's f, here's g. So it's going to be derivative of the first, which would be negative 2 times negative sine. So it'd be positive 2 sine x times sine x plus, I'll leave it as negative 2 cosine x times the derivative of the second, which is cosine x. And to simplify this, it becomes 2 sine squared of x minus 2 cosine squared of x. But it wants it when x equals pi. So I have 2 sine squared of pi minus 2 cosine squared of pi. Now sine squared of pi is 0. So we can just go ahead and cross that out. Cosine squared at pi, so cosine at pi equals negative 1. Negative 1 squared is positive 1. Negative 2 times positive 1, it's going to equal negative 2. So D is our answer. All right. Last page, finally. So this one here is going to be product rule and chain rule. So first thing, I'm going to rewrite it. as to the power of 1/2. So using product rule, we split it here. So x is our f and g is this. So f prime of x is going to equal, derivative of the first is 1, and I leave the second as 2x minus 3 to the 1/2, plus I leave x and take the derivative of the second. So it'd be 1/2, leave the inside as 2x minus 3 to the negative 1/2. But since it's chain rule, I also need to multiply by the derivative of 2x minus 3, which is 2. Now we just need to clean this up so it matches one of our answers. So f prime of x is going to equal, this is the same thing as square root of 2x minus 3. 1/2 and 2 would cancel, so I'd be left with plus x over the square root of 2x minus 3. Now this still doesn't look like any of our answers, so I'm going to try to get a common denominator here by multiplying this side by 2x square root of 2x minus 3 over square root of 2x minus 3. So it's going to be multiplied by square root of 2x minus 3 on the top and the bottom. Now a square root of 2x minus 3 times square root of 2x minus 3 is just 2x minus 3. Then we can add it to this x all over square root of 2x minus 3. So we have to have a common denominator to add those together. We are almost done. Now we just combine like terms and we get 3x minus 3 over square root of 2x minus 3. So A is the answer. Okay, 14, we need the equation of the tangent line of f of x when x equals pi. So first thing, we take the derivative. F prime of x equals, so derivative of 3 cosine of x is negative 3 sine of x, plus 4 sine of x. The derivative of that would be plus 4 cosine of x. Derivative of 5 is 0. And remember, we do not want this as our answer. We need to find the slope. So I need to plug in my x value, which is pi. So negative 3 sine times pi plus 4 cosine times pi. Sine of pi is 0, so that cancels out, which means f prime of pi equals cosine of pi is negative 1. So negative 4 is our slope, which means I can get rid of A and B as my answers. But it could still be C, D, or E. Now I know x equals pi, so I need to figure out what y equals. So f of pi equals 3 cosine pi plus 4 sine pi plus 5. Now we know sine of pi is 0, so I can get rid of that. Cosine of pi is negative 1, so it's negative 3 plus 5. And that's going to equal 2. So our point here is pi 2. Last step is write the equation. So y minus 2 equals negative 4 times x minus pi. Still not quite the answer we need. I need to move this negative 2 to the other side. So y equals negative 4 times x minus pi plus 2, which means D would be our answer. And the last one, save the best for last. This one is going to be a double chain rule. So we have y equals secant tangent of 3x. So lots of trig derivatives and a double chain rule. This should be fun. So it's going to be y prime. The first inside we're going to look at is tangent of 3x. So the outside is secant. And the derivative of secant is secant tangent. So it's going to be secant. So I'll just write that down. Derivative of secant is going to be secant x tangent x. So that's what I'm going to write here, except instead of an x, I'm going to have this whole inside. So it's going to be secant of tangent 3x times tangent of tangent 3x. But since it's product rule, I have to multiply by the derivative of the inside. Now the derivative of tangent of 3x is going to be secant squared of 3x. But we're not done yet because we still have another inside. So this 3x is also an inside, which means I need to multiply by the derivative of 3x, which would be times 3. So now we just need to clean this up to match one of the answer choices. So it's going to be y prime equals, I'm going to move this 3 to the front. So 3, and then notice I have, never mind. So 3 secant of tangent of 3x, tangent of 3x, no, tangent of 3x, this just gets confusing. Tangent of 3x times secant squared of 3x. So if we look, we need that 3 in front. A and B don't have that. Secant tangent of 3x, there it is. Tangent of 3x, that's right there, times secant of 3x. So C is our answer. These are really easy to get confused on, but don't stress too much about those. And that is the end of it. If you need more help on any of the questions, just feel free to ask me if you're in my class. If not, Mr. Kaj, you'll be happy to help you. And yeah.